There is one mistake that is silently killing Prius hybrid batteries across America right now. Not the 12-volt auxiliary battery under the hood. The big one. The high-voltage nickel metal hydride or lithium-ion hybrid battery pack sitting behind the rear seat. The one that costs $2,000 to $4,000 to replace at a dealership. And the worst part is that most Prius owners are making this mistake every single day without knowing it, because nothing warns them until it is too late. After working on hybrids for over 2 decades, I can tell you that the gap between a Prius battery that lasts 250,000 miles and one that fails at 120,000 miles almost always comes down to one habit. One consistent, repeated behavior that either preserves the battery or destroys it slowly. Today, I am going to tell you exactly what that mistake is, why it happens, what it does to the battery chemistry, and what the 1% of Prius owners who never deal with premature battery failure are doing differently. Let me start with something most drivers do not understand about how the Prius hybrid battery actually works. The high-voltage hybrid battery pack in a Prius is not designed to be fully charged or fully discharged, ever. Toyota engineers built the entire hybrid system around a concept called the state of charge window. On a standard Prius, the battery management system keeps the hybrid battery operating between roughly 40% and 80% of its total capacity. That is intentional. That window is not a limitation. It is the protection zone. The battery chemistry in nickel metal hydride cells, which Toyota used in the Prius from the first generation through most of the third generation, degrades fastest at the extremes. A cell that is routinely pushed above 80% charge or pulled below 40% charge loses capacity permanently. The degradation is not reversible. Once a cell loses capacity, it cannot be restored through driving or charging. It can only be replaced. The battery management system, which Toyota calls the hybrid battery ECU, monitors the voltage of every individual module inside the battery pack constantly. A third-generation Prius has 28 battery modules connected in series. Each module contains 6 nickel metal hydride cells. The ECU reads every module independently and uses that data to manage charge and discharge cycles in real time. When one module drifts out of balance with the others, the ECU cannot compensate indefinitely. Over time, an unbalanced pack becomes a problem the car cannot hide. So what is the one mistake? Letting the Prius sit unused for extended periods without driving it. That is it. That is the single most destructive thing a Prius owner can do to their hybrid battery, and it is happening in driveways all across the country right now. People park their Prius for 2 weeks while they travel. They keep it as a second car that only gets driven on weekends. They stop driving it during a long winter. They park it while recovering from surgery. They buy one as a backup vehicle and only use it occasionally. And every single week it sits, the high-voltage hybrid battery moves closer to a failure that costs thousands to fix. Here is why sitting destroys the hybrid battery in a way that driving never would. The nickel metal hydride cells inside the Prius battery pack naturally self-discharge when the vehicle is not being used. This is not unique to Toyota. It is a chemical property of nickel metal hydride chemistry. The rate of self-discharge is higher than lithium-ion chemistry, which is part of why Toyota transitioned to lithium-ion in the 4th generation Prius. But even lithium-ion packs self-discharge over time. In a nickel metal hydride pack, the self-discharge rate is approximately 1% to 2% of total capacity per day under normal temperatures. That means a battery pack sitting unused for 30 days can lose 30% to 60% of its charge without a single mile being driven. Now here is where the real damage happens. The 28 modules inside the Prius battery pack do not self-discharge at exactly the same rate. Some modules are slightly older, slightly warmer, or have marginally different internal resistance. Those differences cause the modules to drain at different rates. When the vehicle sits for weeks, some modules drop below the 40% state of charge threshold, while others remain above it. The pack becomes unbalanced. The battery management ECU is not running when the car is parked, so it cannot equalize the modules. The imbalance compounds every day the car sits. When the owner finally starts the car again, the ECU wakes up and immediately detects the voltage imbalance across the modules. The system is forced to work around the weakest module in the pack because the modules are connected in series, which means the total pack voltage is limited by the lowest cell. Toyota engineers designed the system to protect the weakest module, so the usable charge window effectively shrinks every time this happens. Each cycle of sitting, discharging unevenly, and recovering narrows the working range of the battery and accelerates capacity loss in the weakest modules. Thermal stress compounds the problem. When a nickel metal hydride battery sits at a very low state of charge in hot weather, the cells are more vulnerable to heat-related degradation. The Prius hybrid battery is air-cooled. There is a dedicated battery cooling fan located in the cargo area of the vehicle, usually on the right side behind the rear passenger seat, that pulls cabin air through the battery pack and exhausts it through a vent near the rear of the vehicle. When the car is parked and off, that fan is not running. In summer heat, the battery temperature inside a parked Prius can exceed 100 degrees Fahrenheit. A partially discharged nickel metal hydride cell at high temperature undergoes accelerated crystal formation inside the cell. Specifically, nickel hydroxide crystals can grow on the electrodes, physically blocking electrolyte contact and permanently reducing the cell's capacity. This process is called memory effect in older literature, though the modern understanding is more nuanced. The damage it causes is real, measurable, and irreversible. Cold weather creates a different but equally destructive problem. At very low temperatures, below 20 degrees Fahrenheit, nickel metal hydride cells lose the ability to accept or deliver charge efficiently. If the battery is sitting at a low state of charge in freezing conditions, the cells can develop internal voltage reversal when the car is first started, and the hybrid system demands current before the battery has warmed up. Voltage reversal is exactly what it sounds like. A cell that should be providing positive current momentarily operates in reverse due to its depleted state, which physically damages the electrode material. Toyota's hybrid battery electronic control unit attempts to limit this by warming the battery before demanding full output, but a severely depleted and cold battery can still suffer damage before the thermal management system catches up. Now, here is what the 1% of Prius owners who avoid this problem are doing differently. They drive the car regularly. That is the entire answer in its simplest form. A Prius that is driven at least 3 to 4 times per week, even for short trips, keeps the hybrid battery in a continuous state of active management. The battery ECU runs during every drive and actively balances the modules by controlling charge and discharge in real time. The battery cooling fan runs as needed to maintain proper temperature. The state of charge stays within the protective window Toyota designed. The cells never sit long enough to drift into damaging imbalance, but regular driving alone is not the complete picture. There are 4 specific behaviors that the most informed Prius owners use to actively protect their hybrid battery, and most drivers have never heard of any of them. The first behavior is climate-controlled storage or parking when possible. The hybrid battery cooling fan in the Prius draws air directly from the passenger cabin. This is a critical design detail that most owners miss entirely. The air quality and temperature inside the cabin directly affects battery cooling effectiveness. Owners who park in shaded areas, covered parking structures, or garages during summer months are giving their battery a significant thermal advantage. The lower the ambient temperature during storage, the slower the self-discharge rate, and the lower the risk of heat-related degradation. Owners who park in direct sunlight consistently, especially in states like Arizona, Texas, Florida, and California, expose their batteries to conditions that accelerate every failure mechanism simultaneously. Parking in the shade when possible is not a trivial habit. It is direct battery protection. The second behavior is keeping the cabin air vents clear. Because the hybrid battery cooling fan pulls air from the passenger cabin, anything that blocks cabin airflow affects battery cooling. This includes items stored on the rear seat or in the cargo area that block the fan intake, which is located on the right side of the cargo area in most Prius generations. It also includes a clogged cabin air filter. The cabin air filter in the Prius is typically located behind the glove box on the passenger side of the dashboard. A heavily clogged cabin air filter restricts the airflow that the battery cooling fan can draw. Toyota recommends replacing the cabin air filter every 15,000 to 30,000 miles, but many Prius owners skip this service for years. A restricted cabin air filter is a silent contributor to battery thermal stress, especially in hot climates. The third behavior is avoiding frequent short trips below 5 minutes when possible. Short trips create a specific problem for the Prius hybrid battery. When the vehicle starts cold, the battery management system begins drawing energy from the hybrid battery immediately to power the electric drive motor during low-speed operation. Toyota's hybrid system is designed to use electric-only power at low speeds before the gasoline engine reaches operating temperature, which is one of the reasons the Prius achieves exceptional city fuel economy. But if the trip ends before the gasoline engine has run long enough to allow the battery to recharge through regenerative braking and the engine-driven generator, the battery ends the trip at a slightly lower state of charge than it started. Repeated short trips without longer drives to rebalance the pack gradually push the state of charge toward the lower end of the protective window. Owners who primarily use their Prius for very short urban trips should periodically take the vehicle on a 20 to 30-minute highway drive to allow the hybrid system to fully cycle and rebalance the battery pack. The fourth behavior is monitoring the battery health indicator and understanding what it means. The Prius displays a battery state of charge gauge on the multi-information display, which is the digital screen located in the center of the instrument cluster. Most owners glance at it occasionally without understanding what the position of the charge bars actually indicates about battery health. A healthy Prius battery should fluctuate actively during driving, charging during deceleration and regenerative braking, discharging during acceleration and electric-only operation. A battery that sits at the same charge level without fluctuating, or a battery that the system keeps consistently near the top or bottom of the display, is showing early signs of module imbalance or capacity loss. This subtle behavioral change in the charge display often appears months before the hybrid system warning light activates. Owners who pay attention to this pattern have the opportunity to address battery conditioning before a module fails completely. There is also one specific maintenance step that Toyota does not widely publicize, but that independent hybrid specialists consistently recommend. It is called a hybrid battery reconditioning, and it involves using a specialized charger and discharger to individually cycle each module in the battery pack through controlled deep discharge and recharge sequences. This process cannot be done with any standard diagnostic tool. It requires equipment specifically designed for hybrid battery reconditioning. The purpose is to identify weak modules, remove memory effect buildup in nickel metal hydride cells, and rebalance the pack so that all 28 modules are operating at as close to the same capacity as possible. A properly reconditioned battery pack can recover significant capacity in a pack that is showing early degradation but has not yet experienced module failure. Independent hybrid shops typically charge $300 to $600 for a full reconditioning service on a Prius battery pack. Compare that to a replacement pack at $2,000 to $4,000, and the math is not subtle. If your Prius is starting to show reduced fuel economy, more frequent gasoline engine operation at low speeds where it previously ran on electric power, or a hybrid system warning light, a reconditioning evaluation from a reputable hybrid specialist is worth doing before replacing the pack entirely. There is something else worth understanding about the difference between a failing battery and a battery that simply needs attention. When a Prius hybrid battery starts degrading, the symptoms appear in a specific sequence that most owners misread. The first sign is reduced fuel economy. The Prius is built to achieve its efficiency numbers by maximizing electric-only operation at low speeds and during light acceleration. When the battery pack loses capacity, the hybrid control system compensates by running the gasoline engine more frequently and at lower speeds than it normally would. Owners who track their fuel economy carefully will notice this shift weeks or months before any warning light appears. A Prius that used to average 50 miles per gallon in city driving and drops to 42 miles per gallon without any change in driving habits is telling you something about the battery. The second sign is more frequent engine startup from a dead stop. In a healthy Prius, pulling away from a traffic light in a parking lot or neighborhood street often happens entirely on electric power with the gasoline engine silent. As the battery degrades, the hybrid system loses confidence in the pack's ability to deliver enough current without dropping below the minimum safe voltage threshold. The system responds by starting the gasoline engine more often and earlier than it used to, especially in cold weather when battery performance is naturally reduced. Owners who have driven their Prius for years often notice this behavioral shift instinctively before they can articulate exactly what changed. The third sign is visible on the multi-information display charge gauge. A degrading pack will fluctuate between charge levels in a compressed range, rarely reaching the upper bars and recovering more slowly after hard acceleration. In some cases, the bars appear to jump rather than move smoothly, which reflects uneven discharge across unbalanced modules. The hybrid system is essentially trying to avoid the weakest module's limits on both ends simultaneously, which narrows the effective operating window the display can represent. Only after these three symptoms have been present for some time does the hybrid system warning light typically activate. By that point, one or more modules have usually failed beyond what the ECU can work around. The reconditioning window, where the pack can be rehabilitated rather than replaced, has often already closed. This is why understanding the early warning signs matters as much as knowing the root cause. There is one more detail that almost no Prius owner knows, and it directly affects what happens when you try to revive a Prius that has been sitting for a long time. When a Prius sits for weeks or months and the hybrid battery has deeply discharged, the vehicle may refuse to start even when the 12-volt auxiliary battery is fully charged. This confuses owners because the 12-volt battery is what most people associate with a car that will not start. In the Prius, the 12-volt auxiliary battery only powers the computer, the relays, and the contactors that connect the high-voltage hybrid battery to the drive system. If the hybrid battery voltage has dropped below the minimum threshold that Toyota's hybrid control computer accepts as safe to operate, the system will not allow the high-voltage contactors to close. The car will not start, and the hybrid system warning light will be on. This is not a failed 12-volt battery problem. It is a deeply discharged high-voltage battery problem, and it requires a hybrid battery specialist with the right equipment to safely bring the pack back up to a level where the system will operate. Attempting to jump-start a Prius with a deeply discharged hybrid battery using the standard jump-start procedure from another vehicle's 12-volt system will not solve this problem. It only addresses the auxiliary battery, not the high-voltage pack. Owners who park their Prius for months and then find it will not start are dealing with this exact scenario regularly. The only correct solution is to have the hybrid battery evaluated and charged by a qualified hybrid technician. The bottom line on all of this is straightforward. The Prius hybrid battery is one of the most durable energy storage systems ever put into a mass-market vehicle. Toyota has documented Prius batteries lasting 300,000 miles in taxi fleets. There are owner-documented cases on Prius forums of batteries hitting 400,000 miles without replacement. These batteries do not fail because they are weak. They fail because of how they are used and stored. The chemistry inside those 28 modules is sensitive to two things above everything else: extreme states of charge and extended periods without active management. Drive it regularly. Park it out of direct heat when you can. Keep the cabin air filter clean. Take it on a highway run periodically. Pay attention to what the charge display is telling you. And if it has been sitting or showing signs of early decline, find a hybrid specialist who does battery reconditioning before the system forces you into a full replacement. That is the difference between the 1% of Prius owners who keep the same battery for 250,000 miles and everyone else who replaces it at 130,000 miles, wondering what went wrong. If this kind of honest, technical breakdown helps you take better care of your vehicle, hit subscribe. I have got more videos coming on hybrid system maintenance that dealerships either do not explain or charge too much to fix. Like if it helped. Drive smart. Take care of your Prius and it will take care of you. I will see you in the next one.